biosecurity is something when I came on board 15 years ago, I was like, we need a biosecurity plan. We need a mindset. We need all the employees to think about biosecurity as much as they possibly can. These are things that we take very seriously. We assume that everybody that's coming to the farm is contaminated. They know, especially the employees, how to clean themselves, and where they need to be and where they shouldn't be.
What's going on, guys? Welcome back to another episode of the Coral Reef Talk podcast. We're here with Joey Jones, as always, and we have a special guest today, Chad Clayton from Reef Nutrition. This is going to be a great episode.
How's it going, Chad? Welcome to the podcast.
It's going great. I'm happy to be in the comfort of my own bedroom and had the time between my busy schedule and having a couple of kids to get on with you guys. I'm glad it finally worked out.
Yes, thank you for being here. Today, we're going to talk about Reef Nutrition, and we're going to dive into the world of Reef Nutrition and what they're all about. And you may know them and you may not. So if you're new to Reef Nutrition, Chad, there's some people that may not know what you guys do. What is Reef Nutrition and what are you guys all about?
Awesome. Yeah, so I've been with the company Reed Mariculture, which owns the brand and the product line Reef Nutrition. So Reed Mariculture is a family-owned company, and I've been with the business for about 15 years. I come from aquaculture, so I've worked with fish and things like that in my adventures in aquaculture. And they brought me on to work on zooplankton, copepods, product development, research, things like that. And so what Reef Nutrition is we're a line of foods for corals and fish. We specialize in liquid suspension foods that need to be refrigerated, so no reconstituting, no thawing of ingredients. We tend to keep our animals and phytoplankton and things like that separate per product. We don't combine animals and products. The only combination you would see from us would be our PhytoFeast, which has multiple species of phytoplankton in it. And we sell through retailers, through distributors. We sell direct to consumer. We sell to everyone who has SPS corals, all the way up to big fish that you would have in your aquarium. We even have products that cross over into the freshwater world. And so that's primarily what we do, is we sell foods and help people to, propagate corals, to breed fish, to have healthier fish in their systems. We also have a pelleted food that's very different and unique from our liquid suspension food. So we also have a pelleted food that's very popular in aquaculture as well as in the hobby. And in fact, most of our products are actually popular in aquaculture and in the hobby, whether you're a public aquarium, a coral fragger, somebody who's spawning corals in captivity, all the way to just somebody with an aquarium in their house and it's their hobby. So we tend to offer products for all of those people.
Yeah, and there's a lot of products that you guys have. I mean, Mysis Feast, Oyster Feast, Phyto Feast, Rotifers, copepods, live copepods. So let's kind of jump into that world too. I mean, you guys have two different types of copepods, right? Or a few different types of copepods that you guys work with.
Yeah, that's correct. We have 3 different species, and they're all quite different from each other, and they have a lot of unique purposes. So a lot of people that may be listening in would be familiar with our Tigger pods. This is one of the first live copepods that was available in the United States, retail store market. We collected these live copepods, and the species is Tigriopus californicus. They have a range from Alaska all the way down to Mexico. They're primarily found in splash pools. And so we went out and collected our broodstock from local splash pools along the coast of California. We're actually located in California, so it helps to be nearby. And we were able to get these guys into culture and start working out the details on reproduction. What kind of foods do they like? How long does it take for a tank to mature to where it's ready to be harvested? How do they handle being put into a bottle? Can they handle cold temperatures, hot temperatures, low salinity, ammonia, nitrite, all these things that we know to be harmful to certain animals. And so we hit them with everything and test them to see how durable they are. because we don't want to offer a copepod and work with a copepod that is incredibly sensitive. And some of its sensitivities, we actually were able to breed out of it. And so we culture this organism at our farm, and we're in Silicon Valley, San Jose, California. And one of the reasons why we wanted to start working with copepods is because we knew it was a natural food source as far as a live feed organism goes. Most of what you find in the hobby as far as food goes is like flakes and dead things and dehydrated things and stuff like that. So it was something that we found that was needed, especially for people that were bringing in wild caught fish that are incredibly finicky, that just refuse to eat anything but something live. And success rate is terrible when these animals don't have access to a live food organism. And copepods are one of the most nutritious, most abundant animals on the planet. They're part of virtually every aquatic environment as far as the web goes. The copepods eat phytoplankton, they eat bacteria, they eat organic waste. They store that, they convert that, and then they get eaten by something, and something eats that, and so on. So all of those things that they're getting from phytoplankton get transferred up to that, that predator, that fish that's eating them. And so people that were bringing in mandarin dragonets, pipefish, seahorses, some blennies, even certain species of anthias and things like that, they're bringing these animals in and finding that it was very difficult to keep them because of this missing live feed aspect. And so TigerPods really kind of filled that gap when it came to feeding those animals. We started taking them around the stores and literally saying, look, we're going to dump these live copepods in your tank and you're going to watch your mandarin eat them. And we had store owners go, no way. We've never seen them eat anything that we fed them. We get this live rock from Fiji or Tonga or wherever they get live rock. And we all know that live rock has all kinds of critters on it. And copepods are part of that the zooplankton diversity that you get from live rock, as well as other kinds of pods, amphipods and isopods. And so they would dump the bottle. Randy Reed, who started doing the sales for the company, he would dump the bottle in, and the store owner would watch in amazement as the mandarin went right after this copepod and ate it. And so mandarins typically wouldn't run into this species of copepod. This copepod is not native to where the dragonets are found in the wild. But it is very similar to any kind of amphipod, isopod, copepod, larval invertebrate that they would come across. It's very similar to that by the way it moves, its digestibility, its carotenoid content, its nutritional profile. These are all things that translate to that animal going, okay, that's a food item for me. I'm going to eat it and I'm going to get nutrition from it. So that was huge for people with mandarins. As well as pipefish and seahorse. And then eventually you can try to get those animals to eat dead things, like dead mysis, dead brine shrimp, and dead copepods. And so TigerPods, you can see, you can find them in stores and refrigerators. Luckily, they can tolerate very low temperatures. They can tolerate very high temperatures as well. We grow them in greenhouses, no climate control whatsoever. We feed them phytoplankton routinely from, what we're growing. And we tested them and thoroughly hit them with everything and found that they're incredibly durable. They can be in a bottle for up to 4 weeks easily when kept refrigerated. And we're talking, 33 degrees Fahrenheit. So these animals can tolerate this incredibly cold temperature. And when warmed up, they become active. They can start reproducing, and you can get them into your tank. And so that's just been a very, very powerful animal, live feed organism for the hobby in general, because of its durability, because we don't have to harvest it the day that we get an order, put it in a bottle and sell it immediately, because the clock is ticking, but it's got a shorter time frame. This animal isn't like that. And so luckily it can go through the chain of custody. It can go from us to the shipper to distributor. They ship it, the store holds on to it, sells it to the hobbyist. Boom, it's in the hobbyist tank being fed to those animals that need it. And so after all of that, this animal can survive that, get into your system, be alive long enough to get eaten. And, and in the right circumstances, you could potentially get a population going in your system.
Yeah, absolutely. And they're super important for the entire reef tank, like you were saying. But if you have a refugium where they have that safe place to grow and populate your tank, then you have this cycle of copepods that just keep replenishing your tank. They may get eaten, they may repopulate, but the durability is really important, because I've had people ask me, like, or tell me even like, oh, you're putting copepods in your tank. That's the wrong type of copepods. The temperature is going to affect them, or they're not going to do well in your tank. But yeah, if you really think about it, being shipped out from you guys through all the different shipping, then put in refrigeration, they're going through a variety of different temperature swings. And
Right.
so that's just an insane amount of durability from these little guys. It's pretty awesome.
Yeah, totally. And I can actually take them from full salinity and put them into fresh water for 30 minutes. They stop moving after about 15 minutes. Take them out after 30 minutes, put them back into full salinity, full salt water, and they perk right up, zero mortality. So it's just remarkable that they can even withstand that. And yes, you know, like you said, people are like, well, this is a cold water pod. Some people believe that because they see them in the refrigerator. Well, that's not the case. We're just using that temperature to our advantage so that, you know, the store owner can hold on to them longer, that they can tolerate that shipping, handling, and all that. What makes or breaks this animal is the kind of system you have, the kind of organic nutrient food that you're adding to your tank or that's already there, the predators in your tank. And so these copepods, you know, are very visible to the naked eye. They're very red because they tend to store carotenoids, which are very good at behaving like antioxidants. They also enhance pigmentation. And the carotenoid actually helps to protect these copepods from UV stress. It's almost like they're tanning to protect themselves. And so once they're in your tank, you know, the animals that are predators on these copepods can easily find them, can easily see them. And so mandarins are pretty voracious. I mean, they will literally they just eat all day long. If you watch them, you know, you're looking at hundreds of little pecks on your rocks all day long. It's just remarkable. And they're not just eating pods, they're eating probably worms and all kinds of little critters. And so these animals tend to get eaten before their reproductive cycle can kick in and they can start producing young and next generations and so on. And so what we did because of that, and tigerpods are still a very popular, powerful live feed organism. What we did was we tried to find another copepod that had a better chance of populating a reef tank or a fish only tank or whatever. And we wanted to find something that was smaller, was less conspicuous, reproduced faster, and had the same, you know, attributes. Like they eat algae, they eat organic waste, they eat diatoms, they eat cyano. They're not really picky when it comes to their diet. They will even in nature, they will switch over. If, let's say, diatoms are depleted in their environment, they will switch over to dinoflagellates. They'll eat other kinds of phytoplankton. They will switch to cannibalism in certain situations. And so we found this copepod, Apocyclops panamensis. It is from a different part of the world. You can find these guys throughout the Gulf of Mexico, northern South America, all the way down to Brazil. You can find them in the Everglades up through Florida. I think they are up in the Carolinas. And this species actually has populations in freshwater, estuary, and salt and full saltwater, full marine. And so we were like, wow, this is a durable animal. And there were already people working with it in aquaculture, and they were feeding it our non-viable dead phytoplankton. And they were like, look, I can grow this thing with dead phytoplankton. I don't have to grow my own phyto. This is amazing. They reproduce. They're tough as nails. They're practically impossible to kill. They even outlast any contaminants that they were found to have in their cultures. And so I was like, wow, those, you know, you're checking all the boxes basically for an animal that's right up our alley. And so I started working with it, feeding it non-viable phytoplankton, getting into the culture, setting up dosing systems, making it a reliable system. And we this product, this live animal, a few years ago. We call them Apex pods just because, like I said, they checked all the boxes and they were the best animal that we found that we could work with. They were the top, the pinnacle, the apex of copepods for what we were looking for. And so these guys are more likely to populate a reef tank. They're more likely to invade every square inch of your system. I don't grow them with lights. I'm just in the greenhouse with natural sunlight. So they can live in a sump, you know, they can live in a filter in the back of your system if you've got an all-in-one or whatever, and they can, you know, reproduce themselves, no problem. Now, you know, the only thing that hinders these animals from getting massive populations in your tanks are either other zooplankton, which amphipods are these large crustaceans that you will see, and they're pretty much in every system. In every pet store, you would find them in like live rocks and sumps and things like that. They're pretty big. They're way bigger than the copepods you see in the hobby. And so those things will eat copepods. If their population is huge and you've got a small system and your copepods are trying to populate and get a start, amphipods can hold them back from that. And then you've got fish predators. So if you've got like, butterfly fish, mandarins, wrasses, things like that, these animals that are pecking at rocks all day long. I've even seen dwarf angels doing this. And these animals are also going after these pods. And so it's really hard to say how long it'll take for these animals to populate your system to where you can see them. It's also hard to see these things because once they're in the tank, if they're not on the glass, or you're not, flashing a light in the middle of the night, or whatever, after lights are out, they're really hard to see. And that's the point. They're trying to be cryptic. They're trying to hide. They're trying to blend in with their environment because they are a prey item. There are things hunting them down and they know it.
Yeah.
And so they can be really hard to detect. And so that's why we always recommend, when you get these apex pods, or if you want to add these to your system, add them before you've got fish, add them while you're cycling, add them while you're seeing the ugly phase kind of thing, diatoms and things like that. That's when you get them in there and you let them populate, you let them breed and just start to swell their population so that when you add fish, especially a fish that needs to eat live copepods like a mandarin, you'll know that that population is big enough to supply that animal with plenty of food.
Yeah, absolutely. Because they're going to help clean up that, especially during your cycling phase and stuff, the beginning of your tank. They're going to help clean up the tank by eating the diatoms and everything in there as they populate. So
absolutely. Yeah. And then the third copepod we work with is one that's primarily used in aquaculture. So people that are breeding fish like yellow tang, hippotangs, mandarins. This is a copepod that's pelagic. It was collected off the coast of coast of Hawaii, and so it is not a copepod that would survive in a reef tank. It would literally just get banged across the glass and into the pumps and just taken out by your filter and also by the animals. It's not an animal that will get into your substrate and crawl around. And so that copepod, Parvocalanus crassirostris, which we didn't come up with some funny name for, we sell that to people who are looking to breed those difficult fish, because the larval phase of that animal, of that copepod, and they go through 12 different stages of development. That first stage, when they hatch, after being an egg or an embryo, they hatch, they're small enough to fit into the mouth of a larval yellow tang, or a large angelfish, because it doesn't matter how nutritious the copepod is, if it doesn't fit in the mouth of the animal trying to eat it, then that animal is going to just die. And so that's why copepods are so huge to aquaculture. The fish that we're seeing coming out of breeders, this would have never happened with traditional rotifers and ciliates and microdiets. These things would have never happened on the scale that they're happening now. So this copepod is very useful when it comes to that. And we provide very small starter cultures for people, and we can ship these animals all over the world, which I did not see coming. I did not think we would be able to do that, to throw them in a bag, in a box, and them being so delicate, and they can be in that bag in the dark for 5 days and go all the way to, the Marianas Islands or the Marshall Islands or somewhere in the middle of nowhere in the Pacific Ocean. And so it's really cool that those people, those fishery biologists, those people in aquaculture don't have to go to their local coastal waters or go out into the open ocean, tow a net and collect plankton, figure out which ones are which, and then try to figure out how to grow them individually after separating them. They don't have to do any of that. We've already done all that work. Not just us. There's other people that have been working with this animal as well, and we've all learned from each other. And so it's remarkable. It's really cool for aquaculture when there are companies that provide these live feed organisms as single species cultures. And it's not only great that we can sell them cultures to get things started, but if they have a crash, or if they haven't, produced enough, they can let us know in advance and say, look, I'm going to need 100,000. I'm going to need 400,000 of these animals. Can you do that next week? And so we ramp up production and we try to accommodate. So
yeah, that is amazing. That's a ton of pods that you guys have. I mean, in going back to like Tigger pods in one bottle, you're talking what, like 3,000 plus copepods or more.
Yep. Exactly.
So you guys provide these live feeds and these products to not only the reef hobbyists, but to like breeders, to hatcheries, to universities, public aquariums. So you have a huge operation, probably like millions and millions of gallons of water. So what does that look like as far as, I've had questions where people are like, do I pour the water in my tank? Is there something in the water, or do I have to like pour it through a sock or something and then dump the copepods in? Like with that many products, how do you keep everything like biosecure and keep it from getting contaminated?
Right. Yeah, it is a daunting task, to say the least. We started very small back in the late 90s. Tim Reed wanted to grow oysters. It was either oysters or clams. It was a bivalve in closed recirculating systems. And so he wanted to do this away from the ocean, away from any sources of contamination, so that he could have full control over the animals that he wanted to work with and over the food that he needed to feed them. And so to grow bivalves in a closed recirculating system, people have found over the course of decades that they do best when fed phytoplankton. And not just any phytoplankton, not just something you would find growing in your local coastal waterway or something. This is like specific phytoplankton types that have been separated and put into culture at facilities that keep them very clean and in single species scenario in stasis. And so Tim found that he had to grow all this algae to grow these bivalves, and collaborating with universities in California to kind of dial this in to figure out where am I going with this? Where do I want to go with this? Are clams going to be, whatever I'm working with, is this animal going to, make me money? Am I going to be able to make a living off of this? And talking with people that have been working with shellfish and bivalves for most of their lives, they're like, look, there is a bottleneck in this industry, and it is phytoplankton. We have to grow to scale up our operations, and we're talking recirculating operations that are, spawning oysters or clams, bivalves in captivity, and raising those larvae until those larvae start to form a shell and settle onto a surface, and then start growing into something that would be big enough to sell to market and somebody would eat it. And so these growers were like, look, to grow more shellfish, to grow more bivalves, we have to grow more phytoplankton. And it is incredibly expensive. We have to have dedicated facilities with backups, climate control, proper lighting. We have to have people who are specialized in this, who know how to pay close attention to phytoplankton cultures, who know how to recognize when a culture is crashing, who know how to count cells. These are the same counting techniques that people, phlebotomists and people that are looking at blood cells use. People that are analyzing blood cells, they use the same technology, hemocytometers. And not to mention the fact that growing multiple species increases your chance of cross-contaminating those and turning everything into one species eventually. And you also have to have your backup cultures in a secured room that nobody goes into except one technician. And you're literally taking samples from test tubes, putting them into larger containers like an Erlenmeyer flask, and letting them get dense, and then moving them up to the next larger container before you're into carboys. And there's this whole process that goes on for that. And then from there, you can scale it up to larger systems. Like there are these vertical bag systems that people grow algae in. There's also biofences where they grow the algae on on this substrate that's kind of exposed to the atmosphere, and the algae collects on there, and then they scrape it off or whatever, and that's how they get their algae. And so these people were like, look, these are issues, these are bottlenecks that just people aren't willing to really overcome. It's just too expensive. And so they were like, well, here's an idea, Tim. Why don't you grow the algae and sell it to people? Why don't you sell the milk, so to speak, to people instead of selling them cows? And that's when, the light bulb went off in his head. And so Tim started growing phytoplankton. He started asking everybody, what are the best ones to grow? Which ones are needed in aquaculture? Those are the ones I'm going to work with. And so the operation started small. It started in a trailer, and then eventually went into a greenhouse. And now we are a sprawling facility over multiple acres, and it's all done in greenhouses, and we are easily over 3 million gallons of phytoplankton. In fact, we just added 2 new greenhouses full of, I'd say, at least 250,000 gallons because the demand for algae has gone up significantly. And the reason why it's gone up is because now people can buy it instead of growing it, or they can grow it and maybe not grow, as much as they need, and just buy it from us to make up for what they can't grow. And so there's this kind of thing that has happened where people have discovered us over the years, and they're like, look, I can buy this algae from them. I can feed it to my larval oysters, let's say, or my oyster broodstock. And I don't have to grow the stuff. I can put it in a freezer, or I can put it in a refrigerator and just use small amounts of it because it's incredibly concentrated. We're talking upwards of billions of cells per milliliter. It's that concentrated. And so these people were, these aquaculture operations were able to expand their operations because they could just keep buying the algae and buy more of it instead of expanding their algae culture operation. There's also companies that have begun what they're doing with us in mind. Instead of growing the algae, they're not going to grow any algae. They're just going to be like, we're going to buy it from you guys. We're going to buy enough to store it for months, years, whatever, it depends on the shelf life, and use it to feed our animals. And in a lot of cases, these people go through seasonality issues. So there's spawning events. There's temperature that they can't control. Some of these facilities are near coastal waterways. They're near, bays and sounds and things like that, where they don't have control over the weather, or they're near the equator where they can't really afford to keep a giant facility climate controlled year round. So if they have electricity and they have a freezer and or a refrigerator, then they can store our products instead of having these giant climate controlled facilities and all these people to run the stuff, and all this waste that's generated when you grow algae, and all the fertilizers and the contamination threats and all of it. They can just skip all that. So we have actually helped companies become larger with their operations. We've helped companies come into this without having to grow any algae. And so we've helped to accelerate global aquaculture with this. It's just remarkable. I mean, what we're working with are just the primary producers. We're not the ones that put the oyster on your plate at the restaurant. We have nothing to do with that, except for the fact that our algae is fed to those animals that are then presented to you, at a restaurant or at a market. So it's really cool that we're part of that. It's just amazing. People are eating oysters that were fed our algae in Turkey, in South Korea, in the Maldives. Just you name it. It's really cool that these things are happening, and we're a part of that. And the only way to do that is to grow copious amounts of phytoplankton, and deal with all the seasonality issues that we have to deal with. Luckily, we're in an area where we have abundant sunshine. We have very mild seasonal shifts. We have very few freezes. There's no snow. We're in kind of a drought area, so there's not a whole lot of rain. We do have a rainy season, but typically it's not significant. It has been lately, which has been really challenging. And so we can be consistent. We can grow our species of algae consistently all year round. And what we do is basically what we have is continuous cultures. And so the algae is literally being harvested all day long, every day. The water that it's growing in is recycled through a giant water treatment plant that we basically created ourselves, based on, water treatment plants that handle wastewater for cities for drinking water, or wastewater for aquaculture facilities. We learned a lot from these people, using things like heating the water up to a certain temperature to kill bacteria, pasteurization. We use UV irradiation. We use ozone. We use foam fractionation. We go to great lengths to sterilize that water before it comes back into the culture. Because what we don't want is any of, all this water comes from different cultures. And so it's all coming together and getting filtered. What we don't want is for one of those algae species to survive all of that, and then get into all of our cultures and basically ruin the entire operation like that. It's pretty catastrophic when it happens to one of our ponds. I mean, we're not immune to this kind of thing. It does happen from time to time, whether it's user error or some failure in filtration where maybe a solenoid didn't turn off at the exact time that the temperature dropped too low. All these little things that we're constantly keeping our eyes on. So we filter the water, we keep everything nice and clean, and we recirculate it. And that way we have very little waste when it comes to our water. We're not just culturing the algae and then dumping the water, into a field or something. We're not doing that. We're bringing it right back. We also make our own salt blend. We buy all the raw ingredients and make our own stuff because algae they have different needs than our fish do and our corals do. You would not, the fish and corals would die really quickly in the water that we grow our stuff in because there's low pH, high pH in some of the systems. We pump tons of nitrogen into these systems to feed them nitrogen. We pump tons of carbon dioxide into our systems to give them carbon. And then we add things like iron and trace metals and minerals and things like that. All the stuff that's, fertilizer, basically, all the things that algae needs to grow and multiply itself.
Well, because you want the most control over everything that's happening, right? Because you're growing certain species, certain types of things in each of these ponds and stuff. So having that control, you're not trying to like have a whole aquarium. You're growing phytoplankton.
Yep. Yeah, exactly. Yeah. Keeping everything compartmentalized, keeping it separated is paramount for us. And that brings up a topic. We're growing multiple species of algae. We're growing zooplankton, rotifers, copepods. We're bringing in frozen products and other things from external sources like brine shrimp and mysis shrimp and the copepods that go into our arctopods. We don't grow those. Those are harvested. And so we have to keep all of these things separated. And what we do is we have a mindset and a philosophy, and we apply techniques that are all for biosecurity. So biosecurity is basically the prevention of outside agents from entering a farm or facility, and also to prevent things from spreading within your facility to each other, to each culture. And so biosecurity is something, when I came on board 15 years ago, I was like, we need a biosecurity plan. We need a mindset. We need all the employees to think about biosecurity as much as they possibly can. It's not something that you wake up in the morning and drink your coffee and go, all right, what biosecurity do I need to consider today? We put signs up. We have critical control points where certain people are only allowed to be. And we have signs that say, biosecurity, this area, you could cross contamination threat here, certain personnel only allowed, no bringing in tools, no bringing in carts, no dogs, stuff like that. So what it is basically there are three principles, and I don't have them memorized, so I'm going to read them really quickly, but I think it's important because biosecurity is important, not just to us, but to you guys. I mean, you guys know about coral pathogens and parasites and things. And these are things that coral farmers and people who are serious about this, even hobbyists, have to keep in mind. They have to know about these things. Luckily, the education is huge on coral pathogens and fish pathogens and parasites. So the hobbyists are a lot better educated these days. But basically, we're looking to bio-exclude, so prevent outside agents from entering the farm or facility. We're looking for biomanagement, the way in which spread is prevented within the farm or facility, and then biocontainment. And so procedures in place to stop the spread of disease to the outside world or the threat of contamination to the outside world. That's something that we really don't at our facility need to worry about because we're inland. And so there's really no way our marine phytoplankton and marine copepods are going to get into let's say the local ponds or a local river or stream. They're not going to survive that. There's no way. And so being landlocked also helps us to prevent any contamination that could come from the ocean, because we're near-ish to the coast of California, but we're inland far enough that isn't a threat. And so some of the things that we take seriously at our farm are our personnel. So the people that work at the farm that deal with the algae, deal with the cultures, deal with administrative things, bookkeeping, stuff like that. They are all aware that they are a vector of contamination. They can have contaminants on them and not even know it, and then contaminate our systems accidentally. And so what we do is we identify things that they can bring in and how they can bring them in. Let's say, since we're, near the ocean, let's say we have an employee that commutes to work, lives on the coast, and surfs every day. Now, if that employee wants to go surfing the morning before coming to work, that person needs to come home and shower thoroughly and leave the wetsuit and the surfboard and everything, at home, and not bring it with them to work. that day. In fact, we prefer that nobody goes surfing or fishing before coming to work. But if they do, they know that they're supposed to be in clean clothing, completely showered, completely cleaned, and not have like the wetsuit, sitting in their car and the surfboard still in their car when they come to work. We don't want those things coming to our farm because we consider them all contaminated. The other thing is we don't really like anybody to go to a public aquarium or an aquaculture facility or even a pet store before coming to the farm. If they do, it's change your clothes, take a shower, clean up as best as you possibly can. And also the shoes you are wearing, don't wear the same shoes that you wore to those facilities. Wear something that's completely different than what you had on. And so these are things that we take very seriously. We also don't allow pets, dogs. Dogs are not allowed at our farm because dogs can go off leash and just start roaming around, sticking their nose in everything, getting contaminants on their hair, on their fur, shaking that stuff off into other areas of the farm, and just they can wreak havoc in a matter of hours. And so that's something we take into consideration. And we assume that everybody that's coming to the farm is contaminated. They know, especially the employees, how to clean themselves, and where they need to be and where they shouldn't be. And so this all just protects our assets, protects our asses too. But it's like this is our livelihood. So Tim Reed and his wife and his kids and his family and the board members are like, a lot of them are his friends and family. They own this company, and if we get contaminated to the point where we're completely wiped out, they lose too. They lose, we lose, I lose. The lowest paid employee goes home. We're all unemployed. Poof, done, game over. This kind of thing happened in the shrimp industry with white spot disease. Yeah, anybody listening should look that up. It was devastating to the shrimp farming industry globally. These shrimp would die within days. Entire farms would be completely wiped out in days. And people that own the farm to the people that mowed the lawn in between the ponds, everybody was unemployed suddenly. And this was something that completely took over and wiped out the global shrimp farming. And luckily that's since bounced back, and they have very strict biosecurity rules in place now. There are entire continents, countries that have biosecurity plans in place that are incredibly strict. Australia is one of them. I can't get anything alive into Australia. Forget about it. I have to instruct them, say, look, if you guys have rotifers in Australia or copepods that you can collect on your own coastal waterways, you guys are going to have to do that because I can't ship you a rotifer. We just can't do it. The Australian government does not want to risk those contaminants coming into their country, even though they still have boats coming in and ballast water and all that. Can't really do much about that. I mean, I know that they can disinfect ballast water and things like that, but it's hard to keep everything out. And so a lot of times biosecurity is a mindset, and there's things you can practice, but it's mostly a mindset. What am I touching? What did I put my hand in? And now what am I doing next, kind of thing.
So if for say you did have like a specific system or something get contaminated, do you have like a backup to reset that system? Or
right? Yeah, we have redundancies built into place. So the algae is cultured in compartments. So we have multiple compartments where our algae is grown in. And even within the species, they're grown in different compartments. The copepods are grown in separate tanks that are not connected to a sump. They are independent systems. And so if one of them has a contaminant, we can isolate that system or that one tank and basically, disinfect it, bleach it, nuke it, tear it down, clean everything thoroughly, and then get it back up and running. And that's, we do that from time to time. When let's say we get a rotifer in a copepod culture. We do not want rotifers in the copepod cultures because the rotifers will take them over. Rotifers are like a plague to copepod cultures. They reproduce asexually. They're cloning themselves nonstop, doubling their density every day, and they're also motoring through every chunk of phytoplankton and organic waste in those systems, completely starving out the copepods. And so if in the past, when we have found rotifers, and we haven't found them in our copepod systems in a long time, thank God, but when we have found them, that tank is immediately bleached and started over. And the other thing that's important to note is that when people buy our products, this is something that they need to keep in mind. This is good peace of mind for our customers. It's one thing that the phytoplankton we sell is not alive. It's just incredibly concentrated, and the cells are fully intact, and it's some of the species are frozen, so freezing things kills contaminants. So you've got that aspect with the algae. Then there's with the live copepods and the live rotifers is that we have cleaned them up to the point where it's just those animals in the culture, and that's virtually it. There are some microscopic ciliated protozoans that are really hard to eradicate completely, but we consider them as a benign contaminant. They're things we can live with. They don't reproduce rapidly. They won't take over the culture. They won't kill the copepods. They won't ruin the water quality. They won't outcompete for food, all these other things. When we go to bag and bottle our live feed organisms, we filter them. We rinse them through screens that allow all these little microscopic critters and even any of the macroscopic critters that might be in there that we don't want you guys to have. We filter those out. We do it anyway. Even if we don't find them, we still do it. And so when you buy copepods from us, that's all you're getting in that bottle. And in most cases, you know, with the Tigger pods being in the refrigerator, even if there was a contaminant in there, that kind of environment for that kind of contaminant that's thriving maybe in one of our systems is not a good environment for that thing. And it would probably be amazing for people to take a microscope and go through your sediment substrate, the muck in your systems, and look at it under the microscope. You'd be amazed what you would find. There's all kinds of worms and ciliated protozoans and all kinds of little critters that live in your systems you don't even know about. And so what we don't want to do is help introduce something that you don't have and something that may be harmful. And that's the other thing is also part of our biosecurity is that we don't work with fish and we don't work with corals. We don't have anything to do with any of that. And so there's no way that you could get a pathogen from us. There's no way you could get a coral eating flatworm. We don't have them. You know, those things need hosts and we don't have the host. And so, and even with the frozen stuff that we bring in, we don't even allow it to come to the farm. We have a completely separate kitchen it's basically like a food grade facility where we process those things and put them into bottles. And then those bottles are disinfected. Then they come into our shipping cooler and get stocked and then get ready to be sold. And then the person that deals with those at the end of the day, after they're done doing that, they go straight home. They don't go back into the farm and work with the algae or do this and that. They're done for the day. And so basically our most sensitive room in the facility is our backup cultures. It's in a climate controlled room under positive pressure. We have a laminar flow hood to do all of our inoculations. And, you know, we filter the air. Everything is just sterile. And then, so that's our most sensitive room. That's our most sensitive area of the company. And then our most least sensitive, the dirtiest part of the company, we would consider shipping. That's where all of our products, everything comes together in its packaged form, and then it's thrown together in a box and then sent off to the shipper. And so we consider that to be the dirtiest area of our facility. And you know, like I said, it's just only a handful of us that do the growing, that do the farming. The rest of the employees just stay out of those areas unless they have a clipboard and some information, some data points that they need to write down and put them into a computer. Other than that, nobody goes near the growing areas.
Gotcha. Very specific jobs for each person in each area.
Yes, absolutely. Yeah, I mean, it's like we've got a rotifer guy, and he does our rotifers first thing in the morning. He comes straight in and does the rotifers, bags up whatever we need for the week, does the harvest, counts them, gets their food set up, and then he goes to a less clean job. And let's say he goes to bottling one of our products in our external facility. And so he comes out of the cleanliness to the dirtier areas, so to speak. And he's not allowed to come into the copepod areas. He's not allowed to go into the algae areas, and he knows that. It's totally like it's all clear. And I do biosecurity presentations for all new employees, regardless of who they are. If there's somebody just answering phones to help customers, they got to get this presentation because you just have to have it in your mind. And so that we're all protected.
Yeah, absolutely. You need to know at such a large scale. I mean, providing for not only hobbyists, but like everything out there, basically. Yeah, it's super, super important. Well, Chad, we're going to talk a little bit more about biosecurity in just a moment, but every week on the podcast, Levi gives us a scientific segment where we take a look at a fish or a coral or something in the marine world, and he kind of breaks it down for us. So, Levi, what do you got for us?
All right, so today we have something a little different. We're doing a macroalgae. I don't think we've done a macroalgae yet, but it's dead man fingers. It's a algae native to the Gulf of Mexico, near mid Florida, Tampa Bay area. Codium fragile. It's a unique algae. It's thick, it's super unique, a lot of different growth patterns, and it's kind of seasonal. It kind of starts to pick up towards the end of the winter months and into the late spring, and then it sort of dies off once the waters hit about like 85. It'll start to die off, and you won't see it any longer until the following winter. But yeah, just a super unique algae, and if you're looking for a unique algae to add to like a macro tank or to even feed certain fish, I mean, it's a cool algae, to grow out and something a little different. Certain local fish stores, that carry different macroalgae may have it, but your best bet to actually find the specific species would be like an online retailer.
Very cool. All right, Chad, how many employees are roughly at Reef Nutrition?
So I think we're up to 21 or 22. It fluctuates a little bit because Tim and Lynn's kids sometimes come and work for us, and they're in their 20s now. And they'll fill in for, if we're having a really busy season or busy time of year, they'll come and help out. But it's roughly about 20 to 22. And I would say there's only about three or four people that do most of the growing of the phytoplankton and the zooplankton. There are very few of us that do all of that. And, we've set it up in a way that, we have automated systems and alerts and alarm bells and computers that keep track of things, and we've set it up in a way that we can get all the work done with as few people as possible and keep that machine running, because like I said, the algae is harvesting all the time. Even when we're not there at night, things are still happening, and even when I'm not there, my copepods are still getting fed every 9 minutes, because they could care less if it's dark or light out. They're going to eat the algae in the water column. And so yeah, that's about where we're at. We've actually had to hire a few more people because TDO has really taken off. It has just been gangbusters ever since we got it on bulk reef supply. And it's kind of funny that we have the hardest time getting it into stores, and we were like, how the heck are we going to sell this stuff, because it's a great food, like breeders like swear by it. And we were like, okay, let's go with one of the the big online guys, whatever, saltwateraquarium.com, bulk reef supply. They started carrying it, then we started getting stores wanting to carry it. So it's kind of like the reverse of everything that we've ever seen. So just because the dry food market is just so confusing, there are so many different products out there. I mean, there are flake foods that, companies that have, 30 different flake foods for different freshwater fish. It's like the most confusing thing I've ever seen. And so with TDO really taking off, we had to hire more people, and we're actually looking to reformulate it for the freshwater industry. And once we get into the freshwater industry, we all know that is like, I don't know the number. It's like an order of magnitude larger than the saltwater industry. And so we're looking to really market TDO in a freshwater package with some ingredients that are more what freshwater people are looking for, and market it towards them and get it into that aspect of our hobby. And if that happens, it's definitely going to take off and get pretty crazy. We actually recently just had to have, instead of having labels printed and stickers and putting the labels by hand on every single 3-ounce pack, we're now getting the packs with printed labels. And so there's a printed label in the front, and then all the wording and all the guaranteed analysis and ingredients and this and that are on the back. And so larger font, easier for us older guys to read. And we don't have to like spend days on end putting labels on little 3-ounce packages.
For sure. That's crazy. You guys were labeling those by hand.
Yeah, we were doing it by hand. Absolutely insane. I mean, we were doing Tigger pods by hand for a while until we started doing, 1,000, 1,500 bottles a week. Then we kind of automated things and came up into the modern world, so to speak, instead of doing everything kind of manually, which is just turns you into a crazy person.
Yeah, one thing I really like about the TDO is you guys have like different sizes, even for like, the captive bred side of things where they're breeding clownfish and stuff. But it also like, the TDO A or the B is good for like, feeding smaller polyp corals and even up into the larger pellets. I mean, feeding corals and just different sizes of fish. I mean, it really speaks to every aspect of the hobby. I mean, it reaches a little bit of everything. And I use that stuff like crazy. I mean, all my fish love it. All my corals really enjoy it. It's super, nutritious, as you know, and everything loves it. And it's probably one of my favorite products I ever use. It's amazing.
Yeah, we're stoked at how well it performs. It's just incredible, and the versatility is just we still have, I mean, I'm learning new things every day. I'm learning that people are feeding it to poison arrow frogs, poison dart frog, tadpoles.
Oh, really?
And like swearing by it. They're like, this is like a superfood. Forget all the other stuff that's for tadpoles. And people feeding it to axolotls. I know some people that have fed it to their reptiles and to enhance coloration because of that strong carotenoid that we top dress that pellet with. So yeah, TDO, and it's being used in fresh water. It's just, when the average hobbyist that's not really isn't really savvy to the product sees the label and they're like, Reef Nutrition, and there's a reef scene. They're like, even though on there it says for freshwater and saltwater in the, the little wording, we want to make it more appealing for like a first impression. You look at the pouch and you're like, oh yeah, that's for freshwater. I see a scene of discus and tetras, on the package. And also instead of red, we're going to go with green, like a green Mylar reflective package. Okay. And then tweak some of the ingredients in the top dressing formula. And go from there. So yeah, but the breeders, people breeding angelfish, freshwater angels, cichlids, plecostomus, some of the bottom feeders, catfish, things like that. They're like, this food is absolutely incredible. People in aquaculture call it the gold standard, especially clownfish breeders. Basically, if you're a breeder and you're raising clownfish and you're not using TDO, then you don't have fish that are marketable, because all the other people are using it. And their fish look the coloration for the ocellaris and the percula you're seeing wild type coloration because of this diet. So
awesome. Yeah. One more question I have is, I mean, you guys deal with a lot of different species of like phytoplankton, I'm assuming, obviously. Do you keep every specific species separate before like packaging them into the bottle, or do you grow the different species together with the phyto? Or
right? Yeah. When it comes to phytoplankton, you cannot successfully grow multiple species together in the same culture.
Yeah.
Because one of them is going to win out over the others. It always is the case. There might be one that is the dominant and then one that's barely hanging on by a thread in the culture. Sometimes that happens. So all of our cultures are species separated completely.
Okay.
Starting in our test tubes in our phytoplankton lab, all the way up to the large cultures that we're harvesting every day. Now we also have we got our cultures from a place I think it's in Connecticut, that is kind of like, it's like a seed bank, but it's for phytoplankton. It's a phytoplankton bank. They have phytoplankton that has been collected and separated and cultured from all over the world. And we're talking species that are found in different areas of the world that have different needs. And some of the wildest, like phytoplankton that's bioluminescent, diatoms of all shapes and sizes, things like that. So this place is basically our ultimate backup. And so if we were to have something catastrophic happen to us, like a fire, like an earthquake and a fire all at the same time, that just wipes out all of our cultures, luckily we have insurance for those kinds of things, but we can go to these people and say, look, we want to get our cultures back, because they're basically the same exact thing that we're culturing already. So we would go to them, get these cultures back, get back up and running. I hope to God that never happens, but you never know, and you've got to be prepared for anything.
Yeah,
and so
sure.
We have that. That's kind of like, that's basically our ace in the hole kind of thing. It's like our ultimate backup if something catastrophic were to happen. And we're also learning about new phytoplankton species all the time and how people are using them in like shrimp larval rearing, oyster, clam, abalone larval rearing, things like that. We're always trying to go to the next trade show, which a lot of the aquaculture ones are very high on education and collaboration. Whereas, reef shows are like, where can I find a skimmer? What coral can I buy? These are just people that are sharing information. They're not really selling things at the shows. If you've ever been to one, they're very different. And so we're always trying to keep our finger on the pulse of aquaculture to see if there's any other strains, species of algae that are now known to be very important for, like a larval phase of some bivalve or something. So
like specific species of phytoplankton cater, to different aspects and different organisms, or
so you're asking if like one species can be used on different animals,
pretty much. Sure, if one benefits more than the other or something like that.
Yeah, exactly. There are some diatoms that are really great for golden browns and diatoms when they're put together in a blend are really good for shellfish, for oysters and clams, things like that. There's Tetraselmis is one of the algae that we work with. Very cool algae. I highly recommend looking it up on YouTube. Very motile algae. It's got multiple flagella and it can swim through the water really rapidly. It's a wild thing to look at under the microscope. Well, Tetraselmis has something called a compound called taurine that it synthesizes itself. And taurine has been known to really be great for fish larvae. And it's also known to, Tetraselmis is also known to prevent zoea syndrome, which is for Penaeid shrimp. So food shrimp, people are working with food shrimp, they're breeding them. The larvae hatch and they go through these different stages of development and they reach the zoea stage. And it's kind of a rough stage for them. And this algae, this phytoplankton, helps them to get through that. And Tetraselmis is also a quite large phytoplankton and has been known to be consumed when used as green water by larval fish. And so that one's really unique. The diatoms are very unique compared to the golden browns that we have. Some of the algae are very rich in specific fatty acids that people are looking at, like people that are working with freshwater mussels. They're interested in a certain fatty acid profile, and we can pull from our phytoplankton to create that for them. And so, yeah, the different species have very much different uses, and some people prefer to buy a single species to target certain things in their, with their animals. And then others prefer to buy the blend. They're like, look, we don't know exactly what our animals need, so let's throw everything at them. Why not? Let's let that oyster consume 6 different species of phytoplankton while it grows before we get it to market. Why not? These algae complement each other. Like I said, some of them have fatty acid profiles that are vastly different than the other ones. Some have cholesterol. They have sterols that are really good for animals and development. And so we tend to just, the blends were just basically kind of created haphazardly, and we've tweaked them a little bit over the years, but they seem to be working for people quite well. And so that's like PhytoFeast. So when it comes to the home aquarium where you're feeding filter feeders, non-photosynthetic corals, zooplankton, sponges, tunic, even stony corals, when you're feeding phytoplankton to them, we want to apply that same philosophy. Let's get multiple species into those animals so that they have a more well-rounded diet versus eating just one species of algae.
Yes, very, very cool. Thank you so much, Chad, for jumping into the world of reef nutrition, jumping into biosecurity and how important that is to you guys over there at Reef Nutrition. That's really cool to see because your products are affecting so many different parts of the industry, aquaculture, global aquaculture, and everything. And so biosecurity is vital to your operations. So thank you so much for jumping on the podcast and talking to us today about all that.
You're welcome. It was a pleasure. I look forward to doing this again. And, there's a number of topics I can hit on. So I've been in the industry for a long time. So it's great to kind of diversify, my career. So
very cool. And people can come and meet you face to face at different trade shows and talk to you and ask all the questions about your products. What's like the next show you're going to be at?
So the next show we're going to be at Reefapalooza in Orlando at the Carib Royale.
That's it. Yep, I'm excited.
Place is amazing. I love so Reefapalooza Orlando, for those that are listening, is just a massive show. It is absolutely incredible. And we are the platinum sponsors. Our booth is literally right by the front door. We tend to bring free samples with us. It's like TDO. We'll give away some free TDO. And if you're a longtime customer and there's something you want to try, sometimes I have like my secret stash under the table, a cooler full of goodies. We also sell product out of the refrigerator at the shows at discount. So that's something that you can take advantage of. But yeah, come to the show, pick my brain, because I'm not on the road that often. I could be, but I don't want to be because I have 2 young kids and I want to be the dad that's there, because once they're old enough and I can cut the cord, so to speak, finally, then I can do more shows and they can become, autonomous, so to speak. And so I do realize there are a ton of shows out there. Trust me. Oh my gosh. I could literally do a show like every other weekend. There's that many. It's crazy. I could just spend all my time on the road, but I'd rather not. If I was doing this in my 20s, I'd have been all over it. So yeah, Reefapalooza in Orlando in April, and then we'll be at Reefapalooza in June and up in New Jersey. And so those are the closest shows that are coming up. So yeah.
Very cool. Awesome.
Yeah, you can visit the website to see our trade shows. We have a trade show page. Go to that page and that'll give you an idea of where all the trade shows are. And also we're on Instagram, Facebook. We have a tech support line. If you have any questions, you can reach out to me through Facebook or Instagram. I'm on there all the time, all day long, pretty much. I spend a lot of time in the social media world because it's a great way to touch base with our customers. We're all about grassroots and really being there for our customers. And also, please feel free to call us 888-511-7333. We have at least 3 people answering phones Monday through Friday, which can be very hard to come by these days. And we get a lot of thanks from our customers for that. So yeah, you can find us on multiple different ways. So
yeah, very cool. And if your local fish store doesn't stock Reef Nutrition, you need to get on them. So then call Chad and get some Reef Nutrition in there.
Yep. And I will give them a free refrigerator. So send them my way.
Oh, there you go. That's awesome.
We take very good care of the stores because they are a lifeline for this industry.
Yes.
I would have never gotten my start in this hobby if it wasn't for my local fish store.
Very cool. Well, thank you so much, Chad, again, for being on the podcast. Always a pleasure talking to you about Reef Nutrition and everything. And we look forward to the next one. And if you liked this episode, go ahead and click that like button. Make sure if you have any questions, leave us a comment down below. If you have questions about Reef Nutrition, let us know about them. Thank you so much for watching or listening to the podcast and subscribing to the Coral Reef Talk. And we'll see you next time.
See ya.